Hi guys, this is Saurav here and welcome to this masterclass where we would try to learn how to score 100% in structure of atom for JEE and NEET. Welcome to this session where my strategy would be to take up some critical concepts and help you gauge through the difficulty level and to get through the questions as easily as possible. So, how excited are you guys for this session? Hello Karthik, and just let me know in the chat box that how excited are you for this session. Do you find the structure of atom as a difficult topic or easy topic, or whether you find it as a boring topic? Let me know in the chat box. That will be like the best thing possible. Okay, so my name is Saurav Goswami. People who know me or people who don't know me, let me give you a brief introduction. I have done my masters from, hello Alok, I've done my masters from NIT Rourkela, and I finished my masters in the year 2008, and I've been teaching people for the IIT JEE advanced examination for about like 10 years now, and I've been in Vedantu for quite a while. So you might have seen my videos on the Aspire series or on the Sprint series, and I am here to help you guys get that sweet spot of 100% score in the topic of structure of atom, which also is qualified as atomic structure. ये 11th standard का पहला topic है, and इसमें mistakes होने के chances बहुत कम है, लेकिन कुछ एक चीज़ें ऐसी हैं which we generally don't read, which we generally avoid because they turn out to be really challenging, mathematically challenging. Okay, let's take up those few concepts which we find to be most commonly asked in the examination. Let's take the first question. Let's look at the areas first. So areas agar dekhe, then the areas from where questions are generally asked are Bohr's model, hydrogen spectrum, wave mechanical model, quantum numbers, and radial and angular nodes. They ask questions primarily from these areas, and since from these areas questions are being asked, it's important that you know from which subsection among these questions are being asked. Like in Bohr's model, the subsection from where question is being asked is primarily energy, potential energy, kinetic energy, relation to the total energy, radius, and that's it. Okay, hydrogen spectrum, you need to know the number of lines that you observe, you need to know the spectral series, the series limit, the first line, second line, third line, और ये जो lines हम जो बोलते हैं, what are these? Wave mechanical model, you need to know what is the meaning of Heisenberg uncertainty principle, dual nature, the de Broglie hypothesis. Also, you should be aware of how to identify mathematically the point where the node would be present. Node is a region where the electron density is 0. Quantum numbers, the easiest part, but a lot of people make mistakes in like overconfidence से कुछ mistakes करते हैं. But quantum numbers is like the address of an electron. इसको identify करना बहुत easy है. I would not spend too much of time on quantum numbers because I guess you guys are comfortable with quantum numbers. Just tell me if you guys are comfortable with atomic quantum numbers in the chat box. If you're comfortable with atomic quantum numbers, then teaching you guys radial and angular nodes would be pretty easy for me. Radial and angular nodes calculate करना बहुत easy है, and इसको calculate करने के लिए what we do is we follow a formula based method, but what I would tell you is a non-formula diagrammatic method. Okay, so let's look at the first question of today's session. The first question for today's session is this: the energy of an electron in the first Bohr orbit of hydrogen atom is minus 13.6 electron volts. What will be the potential energy? Now this is how the examination would be testing you. They would not directly ask you hello Megha, they'll not ask you the energy in the fourth orbit, they'll ask you what is the potential energy in the fourth orbit. So how do we do that? So what we do is first we try to identify what is the relation between potential energy, kinetic energy, and total energy. So if the total energy is given as T, and potential energy is given as P and kinetic energy is given as K, then total energy is twice of total energy is equal to potential energy. No signs changed. No signs changed. Like the energy is mentioned in negative. Like what is the meaning of negative energy? Negative energy does not mean that the energy is given out. Negative energy means that the system is bound. It's under an attractive interaction. If the energy is positive or zero, that means it's not in an attractive interaction के कारण ये sign negative हो जाता है. So you do not have to change the signs. But when it comes to kinetic energy, the kinetic energy is equal to minus of the total energy. Kinetic energy will always be positive, so this is what you have to remember. Now, to identify the energy in any particular energy level, we use the formula that energy in particular level, let's say the energy in a particular level n is equal to energy in the first level of hydrogen divided by n square, So what is the energy given over here? Minus 13.6. And fourth energy level, fourth orbit, that means fourth energy level, that will be 4 square, that is 16. So what will be the value? 13.6 by 16 will be equal to what value? This is in terms of electron volts. Now whatever be the value of it, let's say we do not know the value of this, let's try to directly calculate potential energy. So potential energy हम क्या लिख देंगे इसको? Potential energy will be twice of minus 13.6 by 16 electron volts. So this will be minus 1.7 electron volts, minus 1.7 electron volts. So the potential energy of the system turns out to be minus 1.7 electron volts. Can you guys tell me what will be the kinetic energy of the system? Kinetic energy of the electron in the fourth orbit. What would be the kinetic energy? Guys, बताइए क्या होना चाहिए? Kinetic energy कितना होना चाहिए? Kinetic energy will be the negative the total energy. So total energy is minus half of this, that is minus 0.85. Minus 0.85 की जगह हम लिखेंगे 0.85. Okay, 0.85. Mega will write it as 0.85. So this is a very, very easy way of identifying this. Remember these two parts and your life is set. Okay? Let's move ahead. So the next question is this. The shortest wavelength of helium atom in the Balmer series is X, then the longest wavelength in the Paschen series of Li2+. Okay, now this is a question from spectrum in which we apply Bohr's model. Okay, how do we solve a question like this? So what is the Balmer series? What is the Balmer series? So Balmer series is a series which is obtained when electron jumps from any higher energy level to n equals to 2, the second energy level. So n equals to n final, we can write, or I can write n initial could be 3, 4, 5, 6, so on and so forth. N final would be 2. So there will be jumping from any higher energy level to 2. Okay. If you remember, there are so many series. One of them is Balmer. So first is Lyman, Balmer, Paschen, bracket, Fund. I will explain that after a while. So Balmer series is written like this. Lyman, Balmer, Paschen. The Paschen series will be written like this. बताइए what will be Paschen series? Lyman के बाद है Lyman के बाद Balmer, Balmer के बाद Paschen. So Paschen series के लिए n final हो जाता है 3 and n initial हो जाएगा 4, 5, 6, so on and so forth until infinity. ये until infinity तक चलेगा. Okay, so while jumping down, if it jumps to the third energy level, it will be the Paschen series. Now the question is shortest wavelength and longest wavelength. Do you know this relation that energy is inversely proportional to lambda? Energy is inversely proportional to lambda. So when wavelength increases, what happens to the energy? Energy will decrease. Okay, Shiv Pi, we will learn this a while later, but for now there are so many different orbits, like energy is 1, 2, 3, 4, K, L, M, N. So these these orbits turn out to be different energy levels. So if the transition takes place from any higher energy level to any of these energy levels, we qualify them as a particular series. Okay, so finals, if it is 2, it is Balmer. Final, if it is 3, it will be Paschen. Okay, if final is ground state, that is 1, it will be Lyman. So lambda, if is more, energy is less. So if you take short wavelength, that means energy is more, energy is maximum. Can I say that energy is maximum? Shortest wavelength, energy is maximum, but longest wavelength, energy will be minimum. Shortest wavelength, energy is maximum, longest wavelength, energy is minimum. Let's look at how do we identify what is shortest one, what is longest. So highest energy will be given out when transition takes place from infinity to the given energy level. Remember this, guys, that longest wavelength, that means energy is minimum, and this will happen when transition is from n plus 1 to n. That means if it is Lyman series, then the transition from 2 to 1 will generate the longest wavelength or minimum energy. But if it is the shortest wavelength, that means energy is maximum, and in this case the transition will be from infinity to a given level n, where n can be specified. N can have 1, 2, 3, 4, any value, so on and so forth. So shortest wavelength of helium in Balmer series, the shortest wavelength in Balmer series, so shortest in Balmer. So for Balmer series, what will be the value of n? For Balmer series, what will be the value of n? N for Balmer series will be 2. Okay, n for Balmer series will be 2. N will be 2 because Lyman Balmer, it will jump down to the second energy level. Okay. So I can write, there is an equation known as the Rydberg's equation, which is written as RZ square 1 by N1 square minus 1 by N2 square. Okay, we use this equation. Okay, we use this equation to identify the value of lambda. So let's use that equation. If we use that equation, then for shortest, lambda value is given as x, which is equal to r. For helium, what is the atomic number of helium? What is the atomic number for helium? Helium's atomic number is 2. So this will become 4, 1 by N1. Okay. So this I can write it as So you can write this thing as n final, n initial. So this will be 1 by 4 minus shortest, this will be infinity. 1 by 4 minus 1 by infinity. Okay, why I have written 4? Because it jumps down to the second energy level, that is for Balmer series. Okay, now I have to identify for partition for lithium. So let's say the value is Y. Lithium's value is, lithium's atomic number is 3, hydrogen, helium, lithium. So this will be 9. Longest wavelength for partition series, that will be 1 by, so partition series n value is equal to 3, 1 by 16. Can I say this? Longest wavelength, next energy level. So it means 4 to third jump is partition series. So this is what we have obtained. Now we divide both of them. If we divide both of them, can you guys tell me what will be the answer? So I'll write y upon x is equal to 4 upon 9. This will be 1 by 4 times, and this will turn out to be 16 and 9. What will be the LCM of that? What will be the LCM of 16 and 9? Can you guys tell me what will be the answer to this? 16, 9, 144. So this will be 7, 144 by 7. 144 by 7. Isn't it? 144 by 7. The answer to this part will be 144 by 7. So I'll get the answer as, this will be 16, 4, 4, or y will be equal to 16 x by 7. Answer should be B. Answer should be B. How difficult was this question? The question would become difficult. The question would have become difficult had you not known what is shortest, what is longest. But now you know what is shortest, what is longest. Okay? Shortest and longest, that is the only catch in this question. Okay? I hope you have understood this part, and next ever if you encounter such a question, you can solve it very easily. Okay? Let's move ahead. Let's take this question. 3 energy levels PQR of a certain atom are such that EP is less than EQ is less than ER. Okay? EP is less than EQ is less than ER. What is the meaning of this? That means ER is somewhere over here. This is R level. Maximum energy is for R. So R is farthest. This is Q and this is P. Okay, this is what is happening. Lambda 1, lambda 2, lambda 3 are corresponding to R2Q. R2Q jump. When it transitions from R to Q, it is lambda 1. Lambda 2 is Q to P. Lambda 2 is Q to P. This is the wavelength of radiation which is emitted. Okay? And R to P is lambda 3. What is the relation between lambda 1, lambda 2 and lambda 3? How do we identify that? To identify this, we cannot add lambda values. Remember this, guys, that energy is conserved. If you are jumping from the top floor of a building to the ground floor, let's say you are jumping down and you are coming down by different steps, then the total energy remains the same. The total energy remains the same. आप energy same करते हो, okay? Lambda values same नहीं रहेंगी, Okay, lambda values cannot be equated directly. So what we can say is the energy for R2P should be equal to, can I say that energy for R2Q plus energy for Q2P? Can I say that? Bataiye? Can I say that energy which is given out in this transition should be the sum of these two transitions? Yes. So if I apply this, what will be the outcome? So Hc by lambda, that is lambda 3, will be equal to Hc by, what is, why I am writing this? Because electromagnetic radiation is related to lambda as the Planck's equation, that is Hc by lambda. Okay, that will be lambda 1, R2Q is 1 plus Hc by lambda 2. This gets cancelled out. So 1 by lambda 3 is equal to 1 by lambda 1, which is equal to 1 by plus 1 by lambda 2. So right answer should be B. Right answer क्या हो जाएगा? B. Is this part clear? Is this part clear, guys? So if this is understood, we can move ahead. So this is a very, very simple question, has been asked multiple times. The right answer would be B. Okay, the right answer is B. Let's move ahead. So let's look at this question. A sample of Li2 plus absorbs energy and undergoes, okay, a sample of Li2 plus absorbs energy and undergoes excitation to the fourth level, excitation to the fourth energy level, and then de-excites to the ground state. Then the number of lines which are emitted, will be equal to what? Now this is a very simple question. The method to solve this question is that you remember the formula n equals to n minus 1 by 2. That is the number of lines. The number of lines means the number of possible wavelengths. Which will be given out. So number of lines क्या हो जाएगा? Fourth energy level से यहाँ पे आ रहे हैं. So 4, 3 by 2, that becomes 6. Okay, that becomes 6. So the right answer to this question will be B. Okay, the right answer to this question will be B. Okay, Vishwa Subramaniam, it will not be A. Okay, it will be B. Okay, so it's I'm able to see your chart, Rashi, don't worry about that. I'm able to see your chart. Okay, so let's go on to the next question. Okay, suppose in this question I would have taken, rather than a sample, यहाँ पे मैंने sample लिखा है. Okay, this is written sample over here, but suppose I would have written that what is the maximum number of lines that would be observed if a lithium plus ion, if sample would not have been there, and it would have been written like this: a Li2 plus ion absorbs energy and from fourth excited state de-excites to the ground state. What will be the maximum number of lines emitted? So in that scenario, you are taking only one ion, and one electron undergoes de-excitation. So the maximum number of lines in that case would be 3. Okay, the maximum. Please do remember that you have to read the language of the question. For a sample, you can apply that formula, but for a single electron, that formula fails. Okay, that formula is valid if the sample size is very large. Okay, so the formula does not apply to a single Li2 plus ion. Let's move on to the next question. The next question is this. The difference between the wave number of the first line of Balmer series and the last line of Paschen series for Li2 plus ion. Difference between the wave number of the first line of Balmer series. What will be the first line of Balmer series, guys? First line of Balmer series का मतलब ये हो रहा है कि 3 jumping to 2. Okay, electron jumping from 3 to 2. So first line of Balmer series will be written as, I will use this equation 1 by lambda r z square 1 by n1 square minus 1 by n2 square. I'll try to keep this value positive. That is one thing that I have to remember. So difference between wave number. What is wave number? Wave number is 1 by lambda. Wave number is 1 by lambda. So let's say this value is x and इसको हम लिख देते हैं r z square. Okay. For lithium, hydrogen in lithium, so 9 times r 1 by 4 minus 1 by 9, that will be equal to 9r 1 by 4. What will be the so this will be 5 by 36. Can we say that it will be 5 by 36? Now that is for the first line. This is for the first line of Balmer. And last line of Paschen. Last line of Paschen will be the one which is given out when infinity to 3 jump takes place. Last line क्या होगा? Infinity से jump करना. Okay, from infinity to third. So let's say that be y 1 by lambda will be equal to r z square 1 by 3 square minus 1 by infinity, that is 9r 1 by 9. Can I say that? 9r 1 by 9. That's very obvious. So I have to calculate the difference between the two. So x minus y. So this will be 4. This will get cancelled out. So 5r by 4 minus r, that will be r by 4. What will be the right answer, guys? D. The right answer is D. एक बार इक्वेशन समझ में आ गया एंड यू नो दैट फर्स्ट लाइन क्या होता है, लास्ट लाइन क्या होता है, सारे को आप निकाल सकते हो. यू कैन सॉल्व no matter whatever level of question, no matter to whatever extent they try to complicate the question, they cannot make you fall in that trap. Okay, so this is what we do at Vedantu. We try to help kids understand what are the common mistakes in our classroom sessions, which are too damn attractive and too very interactive as well. So we try to inculcate the habit of identifying mistakes so that you don't commit it in the examination. Also, feature wise, there are so many amazing features. Like this question would be asked in a classroom setting with so many different inputs. There is something known as hotspot where you can like answer live. Also, you can get to know the leaderboard. You solve the question, it works on fastest finger. Amazing features on the Vedantu platform. Okay, so let's move ahead. I wanted to tell you guys that how these energy levels are arranged. So इसको मैं बहुत जल्दी से आपको समझा देता हूँ. Okay, let's say this is n equals to infinity. N equals to infinity. This is n equals to 1. Okay, this is n equals to 1. This is n equals to 2. This is n equals to 3. N equals to 4. N equals to 5. n equals to 6, so on and so forth. अब यहाँ पे आप और एक लाइन लगा दो, n equals to 7. Okay, so there are so many different lines, so many different energy levels. Now one very important observation is that yeah, somebody asked, Shiv has asked a very good question, that why is the distance decreasing? Why is the distance decreasing? And the reason for that is the equation that we know. So the equation is E1 is minus 13.6 electron volts. For the second energy level, I will write E2 as minus 13.6 electron volts by n square. By n square, n value is 2. So if I put 4 over here, this will become minus 3.4. Okay, it will become minus 3.4. For the third energy level, the denominator will become 9. The denominator will become 9. If the denominator becomes 9, then E3 will be minus 13.6 electron volts by 9, which is minus 1.5 electron volts. So guys, tell me something. 13.6, 3.4, 1.5. Which has a greater difference? E1 and E2. Which successive energy levels have greater difference? E1 and E2 rather than E2 and E3. So as you keep on increasing the denominator, the energy level values start coming close to each other. Okay, the energy difference starts decreasing. So that's the reason you can see that they are stacking very close to each other. Okay, so let's try to look at what would the transitions look like. So if all transitions are taking place to the first energy level, that will create a series which will be Lyman series. All transitions to the first energy level, not the other way around. If all transitions take place to the second energy level, they'll create Balmer series. All transitions taking place to the third energy level, Paschen series. Okay. All transitions taking place to the fourth energy level, Lyman, Balmer, Paschen, bracket, this is known as bracket series. All transitions to fifth energy level, Lyman, Balmer, Paschen, bracket, fund, and all transitions to sixth energy level is known as Humphrey. Okay, it's known as Humphrey. So depending on what is the final level to which transition takes place, we qualify them as a different series in hydrogen spectrum. This will be the first line, this will be the first line, this will be the final line, this will be the first line, this will be the final line. Okay, now Lyman series is present in the UV region, Balmer series is present in the visible region, and all of these are present in infrared region. Okay, all of these are present in the infrared region. So if I hope this is clear. So whenever you are trying to identify the first line, just the next energy level. Why is this given the name of scientist? यार किसी को तो क्रेडिट मिलना चाहिए, कितना बड़ा काम किया इन्होंने. Okay, somebody should get credit. Who should we give the credit to? The person who has worked on it. इसलिए तो साइंटिस्ट के नाम पे दिया गया. Okay. Humphrey was discovered later. Okay, so that's it. Okay, so please do remember this, guys. This is very, very interesting a topic. Next part is this. Try to solve the question. Suppose that there is a hypothetical atom which gives red, green, blue and violet line in the spectrum. Red, green, blue and violet line in the spectrum. Which jump according to the figure will give off the red spectral line? Which jump according to the figure will give the red spectral line? Now remember, guys, how to solve the question. We know that V, I, B, G, Y, O, R. Okay, red spectral line, which how would we identify? So these are the various wavelengths which are arranged in this manner. V, I, B, G, Y, O, R. V represents violet, indigo, blue, green, yellow, orange, red. Okay, so red means minimum energy, violet is maximum energy, red is minimum energy. Now can you look at this energy diagram and tell me which is the minimum energy, which one is for minimum energy? Okay, so all jumps to would give off the red spectral line. So red spectral line हमें identify करना है कि which is the minimum. तो होना क्या चाहिए? 4 to 1 is not possible. 4 to 1 will be maximum. Guys, n is equal to 1. So all of these lines will be present in. All of these lines will be present in which region? बताइए. I just told you guys. All of these lines jumping to n equals to 1 is Lyman series. Lyman series और Lyman series का मतलब क्या होता है? What is the meaning of Lyman series? Lyman series is in the ultraviolet region. एक ही लाइन दिख रहा है मुझे जो कि which is not present in Lyman series. So the one which will be of lowest energy will be 3 to 2. So answer should be D. Answer should be D. Mysterious guy Aryan. Mysterious guy, you have given the right answer. So the answer should be D. Okay. So please do remember that jumping to n equals to 1 will never give the red line. Okay. So let's move on to the next question. Let's look at this question. Do you find this question intimidating or easy? The question looks very, very challenging to a number of people, but the method of solving this question is very, very simple. Okay, very, very simple. What is given over here is the Schrodinger's wave equation. Our objective is not to know what is Schrodinger's wave equation. Our objective is to attack the question. Okay, when I go to a dinner, I don't worry about how are they cooking the stuff. I focus on eating. So our objective over here is to solve the question rather than figuring out how the equation has been derived. Okay, so how do we solve the question? Now you look at what is being asked. What is being asked? Radial node. A node is a position where electron probability, the probability of finding the electron is 0. Okay, the probability of finding the electron is 0. So if I have the probability of finding the electron is 0, that means this part will become equal to 0. Can I say that, guys? बताइए. If the probability is for finding finding this is 0, so if I square this will become equal to 0. Now when this part becomes equal to 0, let's say there is a number y is equal to m times x times z. Okay, y is equal to m times x times z. If y is 0, then it is quite but obvious that one of these three terms should be equal to 0, isn't it? अगर y 0 है, then either m 0 होगा या फिर x 0 होगा या फिर z 0 होगा. तीनों में से कोई एक टर्म को तो 0 होना होगा. One of them has to become equal to 0, isn't it? Please tell me in the comment section if you have understood this part. One of them has to become equal to 0. Okay, if one of them has to become equal to 0, then I will apply the same logic over here. I will apply the same logic over here. Okay, how do we apply the same logic? This is a number, this is a number, okay, this is a constant. These will never be equal to 0. These will never be equal to 0. But this part can become equal to 0. This part can become equal to 0. Okay. This part can become equal to 0. So my objective is, if I make this 0, because radial node I have to identify, the position of radial node I have to identify, then one of these three parts of the equation has to be 0. This is a number. The number cannot be 0. This is a constant. This cannot be 0. But this can be equal to 0. Okay. So if I apply the same concept and proceed further, then what I can do is, I can say that sigma minus 1 if is equal to 0, then sigma is equal to 1. Isn't it, guys? Sigma minus 1. So there are two parts within this equation. Sigma minus 1 if is equal to 0, then sigma is equal to 1. Now, what is given over here? Sigma is equal to 2zr a naught. 2zr a naught. So if I place the value of sigma over here in that equation, sigma over here in that equation, what will I obtain? 1 is equal to 2zr by a naught, or r is equal to a naught by 2z. Let's say this be r1. This is the position of a node. This is the position of a node. So our first node is at a naught by 2z. Okay, a naught by 2z. Let's try to work out the second equation. What does this equation look like? The equation looks like a quadratic equation. The equation looks like a quadratic equation. Sigma square minus 8 sigma plus 12 is equal to 0. If this is the quadratic equation that we have to solve, क्या होगा बताइए? Sigma square minus 6 sigma minus 2 sigma plus 12 is equal to 0, or sigma minus 6 sigma minus 6 sigma minus 2 will be equal to 0. Okay, sigma minus 6 and sigma minus 2 will be equal to 0. Now if sigma is equal to 6, so I will get two results. Sigma is equal to 6, sigma is equal to 2. If I place the value of, if I place the value of sigma as 6, sigma as 6, then the value of r will be equal to, if I place the value, so r will be equal to a naught, sorry, say r2. If sigma is equal to 6, this will be 3a naught by z, 3a naught by z. If I place sigma as 2, then it will be a naught by z. I have to identify the maximum and minimum position. Maximum and minimum position. What will be the minimum value? ये तीन वैल्यू आपको डिस्टेंस के दे दिए गए हैं. a naught by 2z, a naught by z, 3a naught by z. Which is the largest value in this? Which is the largest value? 3a naught by z. Which is the smallest value? a naught by 2z. So the right answer is C. Right answer is C. Now ever if you get a question like this, would you ever feel uncomfortable? Please tell me, guys. आपके पास कभी भी ये question आ गया, will you ever find it uncomfortable by looking at the equation? No. What you have to do, whenever node is being asked, put psi as equal to 0. Okay. So that is what we try to do over here at Vedantu. जो भी courses रहते हैं हमारे, we try to make things as so damn simple for students that students find it very easy to grasp the basics as well as the advanced. Advanced के लिए अलग से पढ़ने की कोशिश करनी ही नहीं है. बहुत जगह होता है कि your teachers will tell you like short in just equation, आपको पढ़ाया नहीं जाएगा, आप खुद से मेहनत करना चाहते हो कर लो। ओके, सो बट यहां पे क्या किया हमने, आई मेड यू सॉल्व अ एडवांस लेवल क्वेश्चन विद इन 5 minutes of your time. Okay, and I know that you will never forget the method. Okay, so let's move ahead. What is the degeneracy level of fourth energy level of lithium and Li2 plus? Lithium and Li2 plus. How do we identify this? What is the meaning of degeneracy? Degeneracy means equal energy. Degeneracy means equal energy. Now, between these two, which is monoelectronic? Equal energy. I've written Rashi that it is equal energy. Between these two, which is monoelectronic? This one is monoelectronic. And this one is polyelectronic. Isn't it, guys? One is monoelectronic, one is polyelectronic. ठीक है ना? एक चीज याद रखो, ये बहुत बड़ा कंफ्यूजन है लोगों का कि हाउ डू वी, what will be the fourth energy level in both of them. Remember, monoelectronic follows Bohr's model, will follow Bohr's model, and the energy will depend only on the principal quantum number. That means जो prefix रहता है 1s में 1, 2s में 2, 3s में 3, ये जो prefixes रहते हैं सिर्फ उसी के ऊपर डिपेंड करेगा. So depends only on n, and in polyelectronic it depends on n plus l. Okay, depends only on n and it depends on n plus l, where l is the azimuthal quantum number. Azimuthal quantum number s के लिए 0, p के लिए 1, d के लिए 2, f के लिए 3 होता है. Okay, it is 0, 1, 2, 3 for s, p, d and f respectively. Okay, so how do we identify this? What I'm gonna do is I'm gonna use a very simple method. I will write the configuration. Let's say I write all the orbitals: 1s, 2s, 2p, 3s, 3p, 4s, 3d. Okay, I guess you know this. 1s, 2s, 2p, 3s, 3p, 4s, उसके बाद 4d आता है, 3d आता है. आपको इतना मालूम है, ठीक है? Now, for a monoelectronic system, for mono, it will depend only on principal. That means depends only on the numbers which are used as prefixes. So, for mono, the first energy level will be 1s. Okay, the second energy level will be 2s and 2p. This will be the second energy level because both of them have the same value of n. Third energy level will be 3s, 3p, 3d. Fourth energy, this is E1, this is E2, this is E3. Fourth energy level will be 4s, 4p, 4d, 4f, will be E4. The fourth energy level will comprise of all of these because they have the same principal quantum number, that is the numerical prefix. Now, the question was, what is the degeneracy of the fourth energy level? Degeneracy of the fourth energy level. Now tell me something, how many orbitals does this subshell has? Rashi, no, there is no shortcut to this. It will be easier. शॉर्टकट से ना एक दो क्वेश्चन सॉल्व होते हैं, सारे क्वेश्चंस तो नहीं हो पाएंगे. कंसेप्ट समझ लीजिए, इसके आगे कभी भी आपको क्वेश्चन मिलेगा, you will never ever get stuck over here. So S subshell has 1 orbital, P subshell has how many orbital? 3, D subshell has 5 orbital, okay, F subshell has 7 orbitals. So all these orbitals are present on the same energy level. All these orbitals are present on the same energy level. So how many orbitals are present altogether on the fourth energy level? 12, 15, 16. So degeneracy of the fourth energy level is 16. Okay, it is 16. 7 plus 5 plus 3 plus 1. Okay, but in lithium, which is polyelectronic, the energy depends on N plus L. So 1s के लिए N plus L का value कितना होगा? Can anybody tell me? N value is 1, S value is 0. So it will be 1. For this, it will be 2. For this, it will be 3. For this, it will also be 3. But between 2p and 3s, which will have lower energy, the one which has lower value of principal quantum number. So 1s, this will be of E1, this will be E2, this will be E3, this will be E4. All of them individually would turn out to be different energy levels. Okay, that is the reason electrons enter करते हैं stepwise manner में. So which is the fourth energy level? 3s. 3s turns out to be the fourth energy level. If 3s turns out to be the fourth energy level for lithium, what is the number of orbitals it has? 1. So degeneracy will be 1. Okay. If this is understood, then you can solve any question. Please do always remember to look out for whether it is monoelectronic or polyelectronic before applying N plus L rule or N rule. Okay. This is very vital. Okay. Is this part understood, guys? Can you give me a yes or a no? Is this clear? Okay, is this clear? So this is concept which you should always remember. Questions in advanced were asked on this, or have been asked on this, might be asked on this. Okay, so let's move ahead. So how many radial nodes are there in 3s, 4p and 5d? 3s, 4p and 5d. How do we identify that? The method is very simple. What we are going to do is N minus L minus 1 is equal to the number of radial nodes. That is what we are going to use. Okay, that is what you have been taught to use. Okay, that is what you have been taught to use. So let's try to work it out for N minus L minus 1 for this. So for 3s, it will be 3 minus 0 minus 1. That will be 2. For 4p, it will be 4 minus 1 minus 1, that will be 2. For 5d, 5 minus 2 minus 1, that will be 2. So the number of radial nodes, yeah, obviously Karthik, all of them will be 2. Okay? All of them will be 2. But here is the interesting part. How do we identify this? How do we identify this without calculating all of these things? How do we identify this without calculating these things? Okay, so the method is very simple and very elegant as well. Let's take the s orbital. Okay, let's take the s orbital. All s orbitals look like spheres. If all s orbitals look like spheres, then I will assume that s orbitals are present inside concentric spheres. For example, there is a very big sphere . There is a very big sphere which has a nucleus at the center. Okay, there's a very big sphere which has a nucleus at the center. Surrounding it is a small sphere. Then comes slightly bigger one. Then comes an even bigger one. And so we have so many systems of concentric spheres. Okay, so many systems of concentric spheres. Now, how does this help us solve any question? So what I'm going to do is, I'm going to take three different axes. These are three different axes. Okay, there are three different axes. Let's say this is x-axis, this is y-axis, this is z-axis. There are three different axes. You are on the center. You are on the center. Okay? Suppose you are on the center. Suppose you want to go to the boundary of the black sphere, which is the smallest one. You want to go to the boundary of the black sphere, which is the smallest one. Do you have to cross any intermediate boundaries? Do you have to cross any intermediate boundaries? Can you give me a yes or a no? Do you have to cross any intermediate boundaries? No. Okay. To go to the blue sphere, how many intermediate boundaries did you have to cross? How many intermediate boundaries did you have to cross? Moving in either x, y or z direction, how many intermediate boundaries did you have to cross? You had to cross the boundary for the black colored sphere, this small black. To go to the boundary of the blue one, you have to cross the boundary of the black colored sphere, isn't it? Can everybody agree with me on this? Okay. To go to the boundary of the green colored sphere, how many did I had to cross? To go to the boundary of the green colored sphere, how many did I had to cross? 2, black and blue. Okay. To go to the boundary of the black color largest sphere, I had to cross 1, 2, 3 boundaries. Okay. So here is a very important trick. The number of boundaries that you cross are the number of radial nodes. The number of boundaries that you cross are equal to the number of radial nodes. So the number of boundaries that you cross for the smallest one is 0. Number of boundaries that you cross for the next one is 1. Number of boundaries that you cross for green one is 2. Number of boundaries that you cross over here is 3. All of them are s orbitals. All of them are s orbitals. Can you tell me what is the number of radial node for 1s? What is the number of radial node for 1s? So for 1s, I will write it as 1 minus 0 minus 1, that is equal to 0. That means this 0 represents a 1s orbital, 1 represents 2s orbital, 3 represents 4s orbital, 2 represents 3s orbital. Is that understood, guys? That is what is the meaning of the fact that is known as radial. While moving radially, I should not cross a boundary which the number of boundaries that I cross is the number of radial nodes. Okay, the number of boundaries that I cross is the number of radial nodes. Is that clear? This is not given in any of the textbooks that you will read at this level, but at Vedantu we teach this, okay, and teach this in such an interesting way. So this, yeah, it is it is also pretty similar. Now if you are being asked that what is the number of angular nodes, if somebody asks you that what is the number of angular nodes, then what you have to do? The simplest method is that if you know this picture, think of a plane which passes through any point and does not bisect the sphere. Can you draw a plane which passes through the center but does not bisect the sphere? Is there any plane possible? Is there any plane possible which passes through the center but does not bisect the sphere? Can it be drawn? We have to suppose this. You can think of any direction. You can take a direction like this. You can take a direction like this. Any plane that passes through the center but does not bisect the sphere. Can we have any such plane? No. So that is the reason the angular nodes, number of angular nodes is 0. Number of angular nodes is 0. Also number of angular nodes is given as equal to L, whatever is the L value. So L value for s orbital is 0, and because of that because of the method, because of the proof that it does not lie on the plane, okay, so is gonna be number of angular nodes is going to be 0. Okay, it's a very, very elegant method. You can try it out for different orbitals. Okay, so this is a small question for you guys. Try to identify how many angular nodes are there for a dz square orbital. A dz square orbital will look something like this, and this is a small homework for you. Okay, there's a small homework for you. Please write to me at saurav.goswami@vedantu.com. so only for all values of s orbital. Yeah, obviously Shiv, obviously. So this is what a dz square will look like. Okay, this is what a dz square looks like. It's the two lobes within a donut. So you have to identify how many angular nodes are for this. Please write your answers to saurav.goswami@vedantu.com. I'll be happy to reply you guys. So with this, we come to the end of whatever discussion where we wanted to have for the topic of atomic structure. So these concepts are very, very vital, and these concepts can also be learned in a very innovative program that Vedantu is bringing you. So the program is a 1-year long-term course, and it will be taught by a lot of brilliant faculty members who make things so damn simple that it will be like a cakewalk. There's a the price is very competitively placed, and there is an early bird prize, the early bird discount that comes us to be somewhere about 69k. So please do register for the course so that you can be benefited, and please do pass on the message to the friends of yours who want to enjoy the warmth of their house, and घर पे बैठे बैठे ही अगर आपको amazing content आपको चाहिए, please do log on to this thing. Okay, so this is the course link. The course link will also be messaged or the course link will also be present in the video link for this, and please do navigate to the course link to know more about the course. And the end of my class today will be with a quote that your plans be dark and impenetrable as the night, and when you move you fall like a thunderbolt. Okay, so you should be as impactful as possible, but your plans, your effort should be in silence. Let your success be your noise. Okay, and with this message I wish you all the very best, and I hope to see you guys in one of my other Vedantu courses. Bye bye guys.